Okay, problem 16 from the 2025 AMC 12A. Triangle ABC has side lengths AB is 80, BC is 45, and AC is 75. The angle bisector of angle B and the altitude to side AB intersect at point P. What is BP? So I'm going to draw this triangle first, and I'll make it a sort of big triangle. That's not even a straight line. I'll try to draw a straight line. It's here. This is going to be BC here, so we know that's going to be 45. We're going to have some point A, and it's going to look something like this. It's about as best as I can do. This is going to be 75, it's AC, this is 80, and this is going to be 45. And so we have the angle bisector of angle B, and I'm going to call this point M, and we have the altitude from point C, I'm going to call this point N, intersect at point P here. And this is an angle bisector, so I'll just mark that the angles are equal, and we were asked to find what BP equals. So let's just break this down. So first we can find, using just this right triangles, we can sort of find what CN equals, because these are both right triangles here. So triangle BCN is a right triangle, triangle ANC or ACN is also a right triangle. So using that, we can find out specific values of BN and AN. And the reason is because, well, CN squared is going to equal 45 squared minus BN squared. We also have that CN squared, well, this one was using this triangle. Second one, CN squared, is going to equal 75 squared minus AN squared. And so we have sort of these two equations. We can set them equal to each other. We get, because they're both equal to CN, so we get 45 squared minus BN squared equals 75 squared minus AN squared. And what we also have is that AN plus BN has to equal 80, because that's what this entire side AB is. So we get AN plus BN equals 80. So I'm just going to rearrange this equation and factor some things out. So AN squared minus BN squared is equal to, and I'm going to factor out a 15, so we get 15 squared times 5 squared minus 3 squared. And that's just 4 squared, but we can factor this further. So AN plus BN times AN minus BN equals 15 squared times 4 squared. And we know that AN plus BN is 80, so we get 80 times AN minus BN equals 15 squared times 4 squared. We can divide 16 and 80. We get 5, and we can divide this even further. We get 45, so we get AN minus BN equals 45. We also know that AN plus BN equals 80. So adding these, we get 2AN equals 125. AN equals 125 over 2. So I'll just label that. This is 125 over 2. And we also find BN, and we know that AN minus BN is 45, so whatever we want is going to be minus just 90 over 2, because that's what 45 is. And so the answer is going to be BN. Well, that's not the answer, I guess, but BN is going to equal 35 over 2. So we get BN is 35 over 2. So that was just the first step. We have at least some values, and at the beginning we had no values. So this is, we're making progress here. And we want to find BP, and it would be really nice if we knew what PN was, because if we know what PN is, then we can just use the Pythagorean theorem to find BP. So this sort of strategy is called wishful thinking. Like, we just wish we had PN, and using that, maybe we try to find out what PN is. And to do that, I'm going to use two things. First, I'm just going to find out what CN is, the length, and then after that, we can use the angle bisector theorem to find out the length of PN and CP. So first, let's just find out what CN equals, and to do that, we know that CN times AB times 1/2 has to equal the area of ABC, of this triangle. And we want to find CN. We know AB is 180, so we get 40 CN equals the area of ABC, or just equal to the area of ABC. So CN equals the area of ABC over 40. So now let's try to find what the area of ABC is. And I'm going to write that down here. CN equals the area of ABC over 40. And so to find the area of triangle ABC, I'm going to use Heron's formula, which is basically just the formula for the area of the triangle using only the side lengths. And Heron's formula is square root of S, S minus A, S minus B, S minus C. where A, B, and C are the side lengths, and S is the semi-perimeter. So let's find the perimeter first, and let's take half of that to find the semi-perimeter. So 45 plus 75, that's 120, plus 80 is 200. So the semi-perimeter, half of 200 is 100. So we get square root of 100 times 100 minus 80 is 20, times 100 minus 75 is 25, times 100 minus 45 is 55. So this is the area of the triangle. And what we're going to get, well, since it's a square root, I'm going to take out the 10. You can take out a 5, and inside the square root, we're left with 4 times 5 times 5 times 11. So I'm going to take out 10 times 5 times 2 times 5, square root of 11. And so this is 500 square root 11. And so 500 square root 11 is the area, so divided by 40 is going to get us 50 over 4, which is 25 square root 11 over 2. So Cn, I'm sort of running out of space here, but Cn equals 25 square root of 11 over 2. And now we basically made this problem something much smaller. And, since we're not dealing with this big triangle anymore, we're only dealing with this small right triangle here. I'm just going to take that and draw that down again here. So it's going to be something like this. We know this side is 45. Let's see what else. We know this is NBC. We know this is a right angle. This is BCN. This is the angle bisector. And so this is point P here. These are both equivalent. We know what BN is, 35 over 2. And we know Cn, this entire thing is 25 square root of 11 over 2. And the reason we even had to find Bn in the first place is so we can use this Pythagorean theorem, and so we can use the angle bisector theorem. And so the angle bisector theorem basically says that the ratio, that this is basically like NP over Bn is equal to PC over BC. So that these ratios are the same. So we're only interested in NP, so NP is basically going to equal, let's see, it's going to equal this 25 square root of 11 over 2 times, and it's just going to be the ratio of Bn to the sum of Bn and Bc. So Bn is 35 over 2 to the sum of 35 over 2 plus 45. And so let's just go to the next page and simplify that, because that's a messy expression. So NP equals 25 square root of 11 over 2 times 35 over 2 divided by 35 over 2 plus 45. And so this, I'm just going to deal with this thing. This is 35 over 2 divided by 35 plus 90 over 2. So it's 35 divided by 125. And so taking out the 5, we get 7 over 25. So NP equals 25 square root of 11 over 2 times 7 over 25. So these two cancel. We're left with 7 square root of 11 over 2. So this is 7 square root of 11 over 2. So now we just use the Pythagorean theorem to find out BP. So BP squared is equal to 35 over 2 squared plus 7 square root of 11 over 2 squared. So let's just do this. 35 squared is 1225 over 4 plus, this is 49 times 11 over 4. So what is 49 times 11? That's just 49, 9, 3, 1, 539. So it's 1225 plus 539 over 4. And so that is going to be equal to 1864 over 4. Or it's going to be 1764, not 1864. 1764 divided by 4. And so we can simplify this because, well, this is 64, so it's divisible by 4. So there's going to be 4, 4, 1. So BP squared is equal to 441. BP equals square root of 441. And it's beneficial to just memorize that the square root of 441 is 21. So BP is equal to 21. That was a long bash problem, but at the end we got to it.